All right, so let's talk about two definitions. Now, before we get to function families, we need to decide if something is a function at all. So you're going to label graphs one of two things. You're going to either call a graph a relation or a function. Okay. And the way that I like to think about it is that like every graph, everything that has an input and an output value can be categorized as a relation. So, but not every graph is a function. So I think Mrs. Lehman used this example one time. She said, you know, there's dogs and we have different types of dogs. For example, there's a breed of husky and all huskies are dogs. However, not every dog is a husky. You could have, you know, a golden retriever or a cockapoo or a pit bull, lots of different things. So same idea here. Every function is a relation. Our function's like our husky here. Every function is a relation, but not every relation is a function. The difference when you're deciding if it's a function or not, it's a special relation where every input has one output. So, for example, I have these two graphs that you can see below, and I'll talk about why this is the way it is. But this one on the left, this would be an example of a relation. And this one on the right would be an example of a function. And one of the ways we can decide this is by using what we call the vertical line test. I'm going to pause in case you guys, I'll pause for like 15 more seconds. I'm going to put the link for the Jamboard in here one more time, just in case you missed it. And then I will move on. I'm just giving you guys time. If you are writing, I want to make sure you have enough time. Again, these are your notes. So if it's not, you know, exactly what you see on your screen, that's okay. Just make sure you get the big ideas. All right, so I'm going to move on to frame 5 of my Jamboard. If you're on the Jamboard, I'm moving to frame 5. So we said one of the ways we can decide if something is a function or a relation is by using the vertical line test. And what the vertical line test is, it says take a vertical line and run it across your graph. Okay, and remember vertical, I'll write a little note here. Vertical is straight up and down. So take a straight up and down line, run it across your graph. And if there's any time that that line passes through 2 or more points on the graph at the same time, then it is not a function. It fails the vertical line test. It is not a function, or we will call it a relation. All right, so I'll pause just for like 10 seconds here. And I'm actually going to go back a frame and show you how I decided that those two graphs were either a relation or a function. And then we'll practice a little bit more on this frame. All right, so I'm going to go back to frame 4 for a moment, and I'm going to pull up now. It's usually I would take my yardstick and run it across the board so you guys can see. Obviously, it's a little bit different here. So what I'm going to do instead, I'm going to pull up what I've been calling my virtual pencil, and it's just going to be this like bar here. Okay. So the bar is see-through, so we can kind of see what's going on behind it. Now, you guys, I said it's a vertical line test, and so for you, the easiest way to do this is to take your pencil, because we already all have that in our hand, and run it across your graph, okay? And if your pencil is touching 2 points at the same time, or 2 spots on your graph at the same time, it's not a function, it's a relation. Okay, so for example, as I'm running my vertical line across this one, and you're going to want to pay attention here because I will have you guys try it in a moment. If I'm dragging this across, oh, is it not transparent? Uh-oh. There we go. Dragging this across, I'm going to stop there. You can see behind my pencil, I am touching 2 points at the same time. That means that it failed my vertical line test, so it must be a relation. All right? I'm going to do the same thing over here. Now here it looks a little bit different. I don't have a collection of points, I have a line. So you just have to think, does my line cross my pencil in more than one spot? So here as I go along, it's only ever crossing my pencil in one spot. And my pencil's a little bit thick here. It's probably easier for you guys to see on your side. But there's never a time that this is wrapping around and crossing more than once. So what that might look like, let's say I had something like this, where it kind of went, whew. Okay, here, if I put my pencil in the middle, I'd be touching the bottom of this graph and that kind of weird turning point at the same time. That would mean it didn't pass the test and it was a relation. Because I don't have that, it's okay, it passes, it is a function. All right, I'm going to pause. I need a scale of 1 to 5. Where are we at? 1 being, I don't get this at all. 5 being, I think I get it. Just tell me in the chat. Thank you, Caitlin. Thank you, Gabrielle. Thank you, Connor. I'm waiting on Finn and Damari. And yeah, Gabrielle, you got a little bit of a snapshot of this yesterday, but we are going to build onto it. So the beginning part of this is going to look very familiar. Finn and Damari, make sure you're not clocking out here. We got to pay attention. This is important. This is our very first lesson of Unit 6. Thank you, Damari. Thank you, Finn. All right, so let's go on to this next frame here. Now, this first graph we kind of already saw. Oh, I'm actually going to copy and paste my pencil. Here we go. So this first graph we kind of already saw. This looks almost identical. That one does pass the test. It is a function. What I want you guys to do, I'm going to zoom in on my page, and what I want you to do is if at any point you see my pencil touching the graph in more than one spot, I want you to raise your hand. So let's all practice that really quick. I want everybody to press the raise hand button just for a second, just to make sure we know where it's at. I know, seems silly. We're just practicing. Thank you. I'm waiting on, I think, Gabrielle and Damari. Can you guys raise your hand for me? Hey, there we go. Damari, you with us? You got to raise your hand. All right, perfect. So I'm going to lower them. So what I'm going to do is I'm going to zoom in here, and then anytime you see my pencil touching this graph in more than one place, I want you to raise your hand, and that will be my sign that it is touching in more than one location. Damari, did you have a question, or you're just practicing again, raising your hand? Or just practicing? All right, I forgot to grab my pencil before I started this. Okay. So here we go. Let me zoom in. All right, so I'm going to start. Here we go. Remember, raise your hand if you see it touching more than one spot. Ah, we got a couple. Look at that. Yeah, right here. Now, granted, my pencil's a little bit fat here. But yeah, if I were to draw this straight up and down line, you can even look at this y-axis here is our straight up and down line. It's crossing the graph actually 3 times. So that definitely doesn't pass. What would that mean I would call this? Throw it in the chat if you know. What would that mean I would call this? Thank you, Caitlin. Yep, I'm going to call this a relation. All right. So that is a relation. Let's try this last one. All right, I'm going to drag my pencil again, and so you guys are going to raise your hand if you see it crossing it more than one spot. Here we go. We got a couple hand raises. I'm going to stop. Now, it does. I will 100% give you this. It does look like it is crossing in 2 spots. What do you notice about those dots, though, guys? What do you notice about this dot and this dot? Look really hard. I know it's a little bit difficult to see. They aren't filled in. They're open. So what that means, I tricked you guys. Normally, if those were filled in 100%, we do not pass the test. Since these are open, it actually means that that point is not included. So if that point isn't included, we can't say that it's crossing the graph at that point. So be careful on the lookout for open and closed circles. This would actually fall under the category of function. So I'm going to write function here. Oh. And if you want to abbreviate, FCN is the abbreviation for function. All right, so what I'm going to make a little note. Remember that an open circle means that the value is not included, and a closed circle means that it is included. So I want you guys to try this. I'm going to give you about 40 seconds here to look at these three graphs and decide if these are functions or relations. And then I'll be calling on some people, so make sure you are ready. All right, so I put some names on here. I want Gabrielle, you to tell me if that first one is a function or a relation. I want Caitlin to tell me the second one if it's a function or a relation. And I want Connor to tell me the third one if it's a function or relation. Gabrielle, yes, absolutely. This is a relation. Good job. It did not pass the test. Caitlin, yep, this is a function. It looks very twisty and turny, but there's never a time that my vertical line is going to pass it twice. And then Connor, yep, this is a function as well. Oh, I almost wrote Connor again. That would have been silly. You guys are doing awesome. Okay, so I just want to practice a little bit. We're not going to do all of these slides that if you have the Jamboard pulled up, I'm not going to do all of them right now, but I do want to practice it a little bit. So what's going to happen, we're following these virtual instructions. It says you're going to answer either function or relation in a chat box. So what's going to happen is I'm going to pull up a graph. I'm going to give you a second to look at it, and then I'll say, all right, get your answers ready, and we'll go 3, 2, 1, go. And when I say go, you will either press function or you'll either type in function or relation. Okay, so everybody back at the meet, make sure you're with me. All right. Questions before we get started with this activity? I need everybody participating. We're just doing a bunch of chat bombs. All right, I don't see any questions. That means I can get going. So here we go. Get your answer ready. Don't say it yet. Get your answer ready. Type it in the chat and we'll all press enter. In 3, 2, 1, go. Yeah, thank you. Thank you, Caitlin, Connor, Damari, and Finn. It is a function. Good. There is never a time if I drew a vertical line that it would be crossing that graph twice. Good job. All right, let's try this next one. Think about it. Think about it. Don't type anything yet. All right. We're going to press enter in 3, 2, 1, go. Oh, we're not as confident in this one. Connor and Caitlin, you got it correct. It is a relation. Connor, could you tell me why this is a relation? It's a vertical line. Yeah, so if I were to draw a vertical line on top of this is going to seem a little bit redundant. My red line is my vertical line that's representing my vertical line test. I'm actually touching every single point on that line all at the same time. So if you just see a vertical line, that automatically tells you, nope, that is not going to be a function. All right, let's try this one. Get your answer ready. Get your answer ready. All right, we're going to press enter in 3, 2, 1, go. Oh, guys, we're losing steam. I got an answer from Caitlin or Connor. I need answers from Gabrielle, Finn, and Damari as well. Don't leave me. Stay with me. It is a relation. If I were to draw my vertical line, let's say I just draw a vertical line right here. Let me pick a different color. Okay, I'm actually crossing it 1, 2, 3 times. So that means automatically it does not pass my test. It must be a relation. All right. And then one more for good measure. Let's try it out. And I really need an answer. I've heard now from Caitlin, Connor, and Gabrielle. I really need an answer from Finn and Damari too. So get your answer ready for this one. All right, we're going to press enter in 3, 2, 1, go. Thank you. Oh, we got a little bit confused on this one. This one is a function, even though there's a lot of twists and turns. If I were to draw a line here, I'm only crossing 1 time. If I draw a line here, I'm only crossing 1 time. There's never going to be a time that I'm drawing my vertical line and I'm crossing that pink kind of twisty turny line more than once. Okay, so even if it's twisty and turny, that doesn't automatically count it out. Draw your vertical lines and test it and see. All right. So I feel like we're understanding it pretty well. Let's move on to this next half of our lesson. So Gabrielle, this is something that you haven't seen. You're going to want to make sure you tune in. Now that we can categorize something as either, yeah, that's okay, Damari. I just wanted to make sure you're with us. Does it make sense now? Cool. All right. So now we are going to move on to function families. I have some silly family photos up there for you just because they're awkward. So now I'm looking at, once I've categorized if something's a relation or a function, once I've decided it's a function, I can put it in its own little family. So we have parent functions. Parent functions are these, what you see in this category on the left. Oh, you're not there. What you see in this category on the left. If you're on the Jamboard, I'm on frame 15. Okay, so on this category on the left, these are our parent functions. That means these are like the perfect, ideal beginning of the family tree type function. Now, we're going to classify things that don't look exactly like this. They have similarities, but they're not exactly the same. Just like I'm not exactly the same as my mom, but you can see some similarities there. But first, we got to give them names. Just like I have a last name, these functions have names as well. So this first function family name, this is the linear family. Okay, and you're going to learn 6 function families. You want to make sure you write these down. So just do a brief sketch of the graph, the name, the equation, and you can draw another example if you want. I'm going to help you with that. Our equation for this is X. Remember this f of x, that's just like a name of something. It's the same as y equals. X is the actual equation here. And this is what we looked at all first semester. Anytime you see a straight line, it falls into this linear family. It looks like the word line. So maybe for another example, I have my coordinate plane here. And maybe my graph is just, going down. It's still a straight line, but it definitely doesn't look exactly the same as this. We just have to be able to recognize that, hey, it's a straight line. That means it's a linear function. If at any time you're confused, guys, just use the raise hand button and I can go back and help you. All right, let's look at the second function. This is all about what our last unit was. This graph should look very familiar. We just dealt with a lot of them. Do you guys remember what that graph was called? It was what our whole unit was about in Unit 5. So it's kind of similar to like term. Yeah, Caitlin, that's a really good way to think about it. It's like terms. So like terms, for example, they have the same variable and the same exponent. They just might not have the same coefficient. Here we have, you know, similarities, but they're not exactly the same. Oh, yes, this graph is shaped like it is. The shape of the graph is called a parabola. The function family, though, this is the other way we use to describe it. Not sure if anybody remembers. I love that you remembered the word parabola, though. This is called the quadratic family. Okay. And so quadratic, that equation, this should also look familiar. You're going to have an x squared. So anytime you see that exponent of 2, you know you're dealing with some sort of either smile or frown. Granted, doesn't have to be exactly the same. It can be stretched out. It can be super skinny. It can be moved up and down, flipped over. But anything that resembles that kind of parabola shape is going to be in the quadratic family. So maybe for my example, I flip it over and like stretch it out a bunch. Still has that kind of arched shape like our parabola, but it's, you know, it definitely doesn't look the same as our parent function. It's like the weird cousin of the quadratic family. I know I'm moving kind of fast, so if you have questions, you got to let me know. All right, now we get to the trickier stuff. We haven't seen these words before. This next one is the exponential family. And I want you guys, if you are sketching this, which you should be, I want you to add these arrows. I don't like that that graph doesn't have arrows over there. Our equation for this one looks a little bit different than what we're used to. Our equation for this is going to be a to the x. And that a is a number. So, for example, you might have something like 2 to the x or negative 18 to the x or 75 to the power of x. Anytime you see this power of x, that's your hint that we're dealing with the exponential family. So let's say I want to draw another example, right? Your graph could look, you know, something like this. Maybe I've moved it up a bit. That one's pretty similar to the parent. It could look something, you know, a little bit more drastic. Maybe I've flipped it over and moved it down a bunch. Either way, we still have that where one side is kind of flat and one side is either going up or down. Fun fact, if it's going up, this is called exponential growth. If it's going down, this is called exponential decay. But you'll learn about that more in Algebra 2. All right, so I got my 3 function families down. We have 3 more. I'm going to pause. When you guys are ready to go to the next frame, can you type ready in the chat so I know we're good to go? Thank you for bearing with me. I know we got to get through some nitty gritty. Thank you, Caitlin. Thank you, Gabrielle. Thank you, Connor. Looks like I'm just waiting on Finn and Damari. Oh, thank you, Damari. Just Finn. Awesome. We're all ready. Cool. So we got our last 3 functions then. This next one, this one's my favorite. I don't know why. I just like it the best. If you had to describe what this graph looks like, and I don't expect math terms, what does this graph look like to you guys? If you were describing it to somebody, what does it look like? Yeah, thank you, Connor. It looks like a V. So that's the way that I like to remember it. This is called the absolute. Oh, that's ugly. Let me rewrite that. Absolute value family. So the defining characteristic is that it looks something like a V. It has this sharp corner, unlike the quadratic. And the easy way to remember it is that it's the absolute value. This is the only one that has a V in its name. Oh, you remember. Okay, then you might be one up here a little bit, Caitlin. That's good. equation, it will also look like an absolute value. So we're going to put our x inside the absolute value sign. This does not say 1 times 1. That is an absolute value sign. And so for my example, maybe, you know, I have shrunk it down. It's become really tiny and skinny. It's still, we still see that V. That is our defining characteristic of our absolute value. These last two, these are the ones that people get the most confused. And not because their graphs are so similar, mostly because their names are similar. So this middle one, this is called the rational family. And the bottom one, this is called the radical family. So you can see the names are kind of similar. They both start with an R. They both end in AL. But their graphs are very different. This middle graph, you can kind of see it looks like there's almost two separate graphs here put together. It's kind of like a swoop and a swoop. And then this radical, the defining characteristic here, I want everybody to put a point on this side and then an arrow on this side. The big thing with a radical function is that it only goes one way. So with our exponential, we drew arrows going both directions. Radical will only ever go in one direction. All right, so let's fill in those equations. For rational, I got 1 over x. For radical, that is the same. You could also really call this the square root family if we wanted. You're probably going to see radical on our FA though. So square root family, we definitely have a square root as our equation. And then again, if I want to draw some examples maybe that are different, here the big thing, like I said, we have kind of those kind of the two almost separate looking graphs. So maybe I kind of move it up and over a bit. And then for this one, maybe I move it, you know, down and over a bit. All examples of, you know, again, it's not exactly the same. It's not. They're not the same exact graph, but you can definitely see the resemblance, the family character traits here. All right. When you guys are ready here, we have one more frame where I want you to try naming things, and then we'll be done with our notes. So when you guys are done here, can you type ready in the chat? Caitlin, thank you. Connor, thank you. Thanks for sticking with me, guys. I know notes are not the funnest thing to do, the most fun thing to do on a Friday. Damari, thank you. Finn, thank you. Looks like Gabrielle, I think, is the only one wrapping up. So we'll pause a second for Gabrielle, make sure we're all caught up. You're good? Okay, perfect. I just didn't want to move before everybody was good. That's all. All right, so if you're on the Jamboard, I'm on frame 17. What I want you to do for this, and I'll give you like 40 seconds again, I want you to first decide if each graph is a relation or a function. If it does not pass the vertical line test, you can stop right there and call it a relation. If it passes the test, then you have to categorize it and give it its function family name. Okay, so if it's not a function, if it doesn't pass the test, you're just saying relation. If it passes the test, you have to give me the function family. All right, I'm going to give, like I said, about 40 seconds here, and then I'll be calling on some people. So be ready. Caitlin, I'm picking on you again. Sorry. All right, so that should have been enough time for us to wrap up those 3 graphs. You can see I put names above who is going to do each. So again, you're telling me first you have to decide if it's a function or a relation. If it's a if it doesn't pass the test, you just say relation. If it passes the test, I need the name of that function family. So Finn, you're up first. Finn, tell me what did you say this graph was? What name did you give this graph? It is a relation. Good job, Finn. Yeah. So it didn't pass that test. So we didn't even have to categorize it into a family. It's not a function, so it can't be a function family. It's just a relation. Cool. Damari, you're second. Damari, what did you call this graph, that middle one? It is a function, yes. So now let's go back, Damari. Now that we know it's a function, what function family is it part of? So here were your options again. We got this group or this group. You're looking for the one that yours looks like. So I'll give you again, glance. You're looking for the name. And here is what our graph looks like. If you had to categorize that into a family, yep, it would be linear. Good job, Damari. It's a straight line. And then Caitlin, I had to pick on you twice. Sorry, there's only 5 people. So what is our last one named? Exponential. Good. You guys killed it. All right. So what you guys are going to do, we have about 5 minutes remaining. And in those 5 minutes, what I'm going to ask you to do is to do an exit ticket. While we were talking, an exit ticket was posted to Google Classroom. So if you go there, it's a Google form, and it's just going to ask you to answer like 5 multiple choice questions. It's just asking you to look at graphs and to put them in their correct function family. Right? So, I'm going to stop my recording here.